So it looks like they've placed me between, they couldn't find a third speaker from Quebec, so I'm sort of nestled between Raphael and Olivier. So nonetheless, I'm really excited to have been invited by the Canada BIM Council to allow us to share with everyone our experiences that we've been having over the last 8 years. And I'm happy that they gave me some extra time based on the timing that we ended the last presentation, because I have 106 slides, and it should be a 3-hour lecture more than anything, but I'm going to try to condense it. So I'm going to go through some of the pictures very quickly, because they're more background than anything. So it's not a plug for Red Cage, by the way. I just that they happened to do this video for us a while back, and it's actually, you guys can probably Google that. It's about 7 minutes, and we talk about the whole process for that particular project. But let me share with you some of the aspects of, I think, what I hope you get out of this presentation in a nutshell. So how can BIM guide development and renewal in general? You know, can BIM be a catalyst for design excellence? And yes, it can. And I think the building that you just saw is an example of that. And can BIM drive schedule and budget certainty? Yes, it can. And you know, can we use BIM basically for offsite fabrication? We have, and I'm sure others are doing it as well. And just basically in general, what's the power of BIM in the general terms? Not specifically to buildings, but to build things, if I can use that analogy. So this is what I'm going to cover quickly. The parts 1 and 2, I'm going to go very, very quick through that one. And number 3, I'll focus a little slower on item number 4 and 5, because I think that's where everyone is interested here about this conference today. I'm just curious to know how many architects are in the room, besides myself here. So there's fewer engineers, fewer contractors. Almost, okay. And the most important people that I need to know who's in the room, outside of some of the people I've already met. Owners. Where are the owners? So there's only a few owners, and I see a lot of empty seats. And I think we have to do our job better, I think, to get them out here to listen to what's happening to the world, to Ontario, to Canada with regards to the use of BIM. And hopefully each of the owners that you've heard today and myself will actually illustrate why we have to continue to think of our environment. And when we all live in a world of the Internet of Things, we have to consider what our construct is going to look like in about 10 years, 20, 30 years from now. So just for those who are not familiar with York University, we are at the north side of Lake Ontario, about 25 kilometers north of the shore of the Great Lakes, Lake Ontario in this particular case. We have 3 campuses. Our historical campus is right here at the north end of the city, about 25 kilometers from the shore, where we started the university, and we're in the process of building our 3rd campus. Our first phase is $250 million. It's to accommodate 15,000 students when it's fully built out. Let me just go here. So there's some stats here, some general stats about the university. We're a $3 billion asset university. We're the 3rd largest university in the country, 185 hectares on our main campus. Our smaller campus is about 30 hectares, 10,000 students, 55,000 students, and 10,000 faculty and staff. We're 26 plus research programs in the university, and we're continually to evolve. Our operating budget approximately of $1 billion for the year. And the big part for us that's very important that people forget is we're getting bigger. And not because we're getting more students, we're getting bigger because the university is focusing more and more on research, and therefore we're building more infrastructure to support that infrastructure. So the net ratio of space to students or to researchers is going up, while maybe the steady state of the students will remain the same, and maybe the researchers will go up. So perhaps as it was noted in the previous presentation by the airport in Quebec, they were considered a bush airport, and maybe we were considered a bush university to some past day, because it started at the north end. It's bounded by basically an agricultural site, and here's the first president, Murray Ross, with a vision of a super university in the late 50s, early 60s, and the beginning of the university started in 1967, when initially they contracted a consortium of architects that really established a design excellence at a time with this kind of mid-century modern architecture that some of us love as architects and others very much hate it, especially if people who have to maintain and operate these buildings. So as I fast forward, we incorporate art into a lot of our public realm of the university. This is how the university started in 1959 when the University of Toronto basically gave us the land for $1 in the middle part of campus. So this is the older part of campus. This is our current campus, now urbanized after, if you think about it, over 50 years, coming on to 60 plus or minus years. And to our luck, we now have a subway station right in the middle of campus, designed by Norman Foster's office here, and another one by Will Alsop, designed over here. And all of that's also changed the way the university is going to expand because of the fact that we're now accessible to the entire GTA. As people come from afar and near by public transit, I would say about 80 to 90% of the people are now have been taking public transit. We used to have 2,000 buses a day, both regional and local, on campus every single day. And of course that's changed, and I'm really excited for that change because it's going to allow us to create architecture like this. This is fast forwarding to the year 2000. Here we are, some wonderful buildings with some of the well-known architects in Canada and engineers working on our faculty. I'll fast forward a little more. This is a project that we did in 2010 that's won an award for library renewal. And then I'm going to fast forward to some of the things that we end up doing, converting an old hockey rink from the early 70s into a state-of-the-art health sciences facility, and repurposing and basically minimizing our footprint by renewing our infrastructure that's on our campus. Our Osgood Hall Law School, the oldest law school in the country. Of course, York is going to have to say the best law school in the country. It only goes without saying. And this is when we began to kind of consider building information modeling. At this point, maybe we might have referred to it as BIM Light. Maybe many of you have heard that. So in this particular case, the skin and the structure was done in BIM, but the rest of it wasn't. And I always kind of scratch my head and wondered why. So I'll come back to this a little later. As we advanced, worked with Dal Lestage from Montreal on a project in our Glendon campus, which is our French language campus. Canon Design with Arup and an international consortium built this facility in collaborative BIM through Infrastructure Ontario, which was our first foray into the introduction of working with Infrastructure Ontario. So if you were in Ontario, you would understand my sensibility about working with Infrastructure Ontario, and I openly say this. Did we get a good product? Maybe in some ways we did. And the Bergeron, you saw the video, the Bergeron Center for Engineering Excellence. This particular building, the cloud, which is what we call it, would not have occurred, would not have been imagined, would not have been implemented if it wasn't for the implementation, the active implementation of every aspect from conception to the end of construction to operations maintenance in a BIM environment. It wouldn't have happened. So a couple of projects that we're working on, I'll come back to these as I talk about BIM a little later. An interesting building we're about to embark. I'll share a little more about that. So what were the changing drivers that made York University consider, outside of the fact that I had already been introduced to BIM back in 2006 and working with a large international A&E firm where we basically, at that time in 2006, more than 50% of the project they did all over the United States and around the world were already done in some kind of collaborative BIM, which included architecture, mechanical, electrical, and structural. So we actually took that and put it to another whole dimension when we added landscape architecture, civil, et cetera, et cetera. So as we think about it as owners and operators and where all our money goes on a day-to-day basis, on a month-to-month, year-by-year, is in this area here. So if we can make our buildings much more efficient and reduce the cost of maintaining and operating, that's usually about 50+% to operate a building in just space heating. If we can make our buildings smarter through planning, design, construction, it means that we can reduce that arc in that circle. Furthermore, as we know, buildings occupy almost 50% of all energy usage in North America. These are statistics from the United States, but it does not differ in the Canadian context. It just does not. And so we have to consider how much smarter can we create our processes such that it's integrated and collaborated that allows us to reduce exactly this amount. This is crazy. Our stock of buildings at our university, in your cities, in your provinces, is extensive to the extent that we may be talking about new construction, but I think the power of BIM is really in existing structures, and I'll show you in a minute what I mean. So we always, I'm always arguing with the folks who fund our projects. there's an initial investment of capital cost, and we forget the actual, the actual cost of operating that building. As you see, over 50 years, how much embodied energy goes to maintaining and operating these buildings. It's considerable. So if we can keep the line fairly horizontal to the initial capital investment and bring these down, that's a win-win for everyone. And if you think about it, with the greenhouse gases initiatives that, at least in the province of Ontario, and also nationally, that it's starting to evolve and manifest itself into new policies for the whole province, it means that we all going to have to think about how we plan and design these particular buildings and operate them for their life of their existence. So, something that's interesting in terms of this particular data, and for me as an architect, it really pains me to see that 92% of owners say that architects' drawings are insufficient. As an architect who I was a receiver of RFPs and respond to RFPs, and then after I deliver a building and I'm told that that's my performance, and that's just not the architects, by the way. It's probably the engineers, it's probably the contract, it's everyone put together, because there's a lot of waste, right? So these statistics are really important, because with these statistics, we can begin to sort of calibrate the way we actually might conceive our buildings and how we operate our buildings once they're constructed. When you think about the decline of the AEC industry over the last 50 years or so, and every other industry, their improvement, 150% improvement, while AEC has gone down by 15%. What does that say? Now, I know gravity is our nemesis, because we have to build from the bottom up. Can't build from the top down. Gravity is always going to be there. And so we always have to consider how we actually integrate and collaborate. And we always have to keep the project in mind, not our independent kind of responsibilities as an architect and an engineer. And that's been part of the problem. But if we think of ourselves as a team, and I think if anything, BIM has created more team environments than ever before. So traditional processes, you get traditional results, right? And no disrespect to my engineer friends in the room, but this is what happens. So let me take you to BIM at York, as I look at my watch here, because I think have another 80 slides to go. So BIM at York. So it's, this is our digital York. This is what we have to deal with. As York grows and facilities, its asset management becomes increasingly complex and important to deal with. So we're starting to utilize a variety of technologies, which we have been for a number of years now. As you can see from BIM's CAFM and GIS, Maximo, which is our work order system, Archibus for space management. And by the way, Maximo and Archibus works quite well. They have a plugin for Revit, which allows basically our BIM models to tie into our work order systems. So we're working through that with our finance department and procurement in order to integrate them better. And so we're working through that process of converting files that are coming out of the models through COBie to then integrate into our Maximo. And we've been actually going through the exercise to trying to determine, as to where the information should reside. So we're going through that. We're also using, obviously, GIS and ArcGIS to map all our information, and we're trying to merge both BIM and GIS as well as we move forward. So let me take it a little bit. This is how we've adapted, this is a little chronology on the way we've adopted BIM at our university. So in 2010, we started our first project for an existing complex. It's about 834,000 square feet, about 80,000 square meters thereabouts. And we require parametric tool use by the team. And this is for an existing building on campus. So I would say that was our first formal foray into the BIM world, because we actually put the language into the request for proposal for that very purpose. Then we moved on to 2011, where major interior renovations started to incorporate BIM processes. And I'm talking about spaces that are 20,000, 30,000, 40,000. Maybe that's not in the same scale of Alberta infrastructure or the government of Canada, where we may be talking 200,000. But for us, it was major. We then developed our first BIM execution plan in 2012, where we actually dictated pretty much everything that needed to be required of the design team as well as the implementors. And that's all the fabricators, all the subtrades, and the general contractor. And then what the purpose of all that information was going to be. So we actually explained quite clearly, this is the reason we need you to actually work in this BIM environment. And so as we move forward, our first capital project that was then rolled out using our first BIM execution plan was that video that you saw. And that was the general contractor partner and the landscape architect who worked in BIM for our particular building. I'll speak about that in a second as well. We've now moved through these various phases. And right now we have about $450 million of capital work. We constantly have about $500 million. And I would say right now about 50% of that, because it's building related or interiors, it uses or implements some form of BIM throughout the process. And we're in actually our third version, maybe 3.0 of our BIM execution plan. And we have 2 BIM execution plans. One for CCDC2, stipulated sum, and one for CM, because they're a little different. And we're in the process of now conceiving a project which we hope to be integrated project delivery, which will have another set of BIM execution plan for that delivery methodology as well. So our commitment to BIM is, as you can see by the awards, and I'm happy to say, we won the Design Award in 2016. We won the Owners Award, the Best in BIM that year. So we're pretty excited, and we're committed. And as you can see, the following year, we won it again as the Owners Award. So we're going to see if we can do a three-peat this coming year. We have a couple of projects that are also fully integrated BIM. We're hoping that's the case. But I'm also excited if others win this award, because I don't think it's fair that we're the only ones achieving those milestones. I think the accomplishment would be when everyone else receives awards. And then it speaks to actually where we actually were and where we actually are going. So our trajectory then hopefully will be a different one. We've been involved with smart buildings for a number of years. We sit on the owners committees, our execution plans, and we currently have completed, we're in the process of completing 5 major capital projects, and I'm talking about 116,000 square meters, which is, for those who like feet, 165,000 square feet. We have all our projects are around over 100,000 square feet, about 200. They're all being delivered in fully collaborative, integrated BIM for the purpose of facilities management and operations and maintenance. So, and we have about 15 other renewal projects on the go. This is when we won our award, and if some of you who are not familiar with IBC, the Institute for BIM Canada, the manual itself has our building on the cover and the tabs. And we're pretty proud that IBC felt that our project should be displayed in this fashion. And we contributed to some of the documentation that they used, just like we had learned from many others, like Penn State, and there's other universities in the United States. Princeton has another one. There's another one in California. We've learned from others, and we're happy to share and contribute as well. The more we can share, the more we'll learn from you, the more I think we're all going to go. This is where we've spoken about BIM. We've been talking about BIM at York University as we advance the different realms of BIM since 2012, right across from procurement divisions to operation officers of all sorts. We've spoken to everyone, and the more we speak to them, and the more we learn about ourselves and perhaps what else we need to improve as we go forward. So, why BIM at York? And this is the reasons, right? These are the very reasons. Many of you may already be aware of it, but for us it's very, very important because it gives us the tools and the information to make decisions in a smart way. Because more often than not, we don't have enough information that then you can actually make a recommendation to your vice president and others. And especially working with your procurement department, it helps them understand what our goals and objectives are. So but for us, the most important part of it is to go through the process to get all this information, the metrics, the integrated design, so to basically achieve this. Operations and maintenance integration. That's really our ultimate goal, and therefore reduce our maintenance costs. We don't have the kind of funds to maintain, and I always hear this all the time. There's always money for capital projects. There's always money for major renovations, but they have pennies to maintain those buildings and operate them. So how do you actually change that paradigm? And how you do it is by making sure that everything we do beforehand is done in such a way that we minimize the output at the end for those who have to operate and maintain those particular buildings. But for us, most importantly, I think it helps us to create better planning decisions and planning reliability for a lot of our capital projects from a campus perspective, as well as obviously making good decisions about design and so on. So many of you have already seen this curve today a few times. And I want to focus a little bit about this because this is truly the way BIM works. So when we receive basically proposals from architects and engineers, and I see the fees still structured the old way, 10, 12%, 10, 12%. I've been there, done that, right? So when I started to work in a BIM environment, we started to adjust where we spend our money. So we were moving our fees from design development or construction documents to the front phase and moving now the 10, 12% to 18% or even 20% for schematic design and also design development. Thereby, the objective is to reduce the amount of effort during your construction documentation phase. Doesn't that make sense? Where you can make the most impact? You don't want to do it here because you know what that contract is going to say? Happy to make the change. Cha-ching, 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 right? And that's not what we don't want. So this is why when I see proposals now, I always have a conversation with the architects and engineers. Are you sure you understand we're doing it in a fully integrated collaborative BIM? You cannot be charging the fees in the manner that you're doing it. You're going to be short during this first phase. So they're happy to change it. And that's because it's coming from us. BIM advantages, lower cost. They say this is some data from the UK. 33% lower cost and reduction of initial cost construction. Lower emissions, improvement in exports, faster delivery. I mean, this is data that's coming out of the UK. Other benefits to owners, faster drafting, coordination, collaboration. And for us, I think the most important ones, if you can do this, the collaboration and the coordination much better, it means that everything else is going to work much better. The communication is much more transparent, and I think it's a lot more collaborative. And what it's done for us as a university, and maybe it could work for other owners, is it's brought our operations and maintenance folks to the table a lot sooner. We involve them in the conversation. They don't shy away about BIM for operations and maintenance. They actually tell us this is what we need inputted into your models, that they can then extract the information for their particular responsibility. So getting them involved early becomes very, very important. So I see I'm running out of time. 50 more slides to go. So this is basically a map. We did this for a purpose. Every building you see in red on this campus has got some kind of BIM structure of some kind. So maybe the shell and the structure are already modeled. Anything that's in yellow is the BIM, fully BIM integrated. That means civil, landscape, and all the infrastructure, and of course all the main disciplines all incorporated into that. So that's the Bergeron building, the cloud that we call it, our new building that we're building, that we're going to do there. All these other buildings, they're all in fully integrated BIM. And you see a scattering of all sorts of interior renovations all over the campus that will utilize BIM in some way. So let me take you to a quick study, which I already spoke about. This is the existing building, how we started. 5 buildings. We basically asked the consultant team to look at all this, from space planning, building design, sustainability, stormwater management, code life safety, et cetera, et cetera, et cetera. And so they were selected. It happened to be a team not from Canada, I have to admit, and it's unfortunate. And they produced a model of the structures for ourselves. We actually looked at a number of scenarios. We explored those various scenarios from different vantage points. For example, every option had an opportunity to look at energy and what that means in terms of return of investment. Using the model, we were able to do so many other analyses that then we can inform our vice president of the university, look, we need $6 million for this, we need $5 million for that, we need $20 million for this, and so on. And so when you provided these kind of metrics and what the payback, as a result, they understood that if we wanted to improve the energy of those particular concrete buildings of the 1960s, it meant that we had to change the windows to improve the energy performance, or maybe deal with solar shading because they happened to face west, and most of the glazing was on the west side. Something that I guess in the 1950s and 60s people weren't as aware. So we looked at all sorts of measures and how we can improve our energy efficiency utilizing that base model. This is one team did all this. As a result, we ended up with all sorts of information that we were able to then use to make decision about our next phase. And so our next phase was this. We took that study, it was a $300,000 study, by the way. And then this was the first foray, first phase, landscape architecture using BIM. And then we've basically renovated this entire sort of basically desolate area, and now we've greened it. We're getting $100,000 back from the city of Toronto for basically greening that podium that was basically concrete for about 40 years. And as a result, we're going to put that back into the particular project. So let me advance forward. This is our first project for design, for manufacturing and assembly. We did this in-house. I happen to be the architect of record for this project with our friends, so we won this award in the United States, and it was designed as a relocatable structure, so we can relocate them for robotics research. It was basically designed in our office, taken to the fabricator, brought on a flatbed, craned in, and there they are. This was only a $500,000 job. So can you use BIM for something small, something large? It's scaleless in my view, it's scaleless. So let me keep going fast forwarding here. Department of Finance, major interiors, a small interior project that had some complexities in terms of life safety, access to egress, etc. We explored and basically did the model of the area as well as the shell of the building, and we explored how we're going to do this insertion, this intervention into this three-story volume that basically bled into a one-story volume, and how do we actually deal with the fire separations and assembly and travel to exit. And we did it basically 375,000 using BIM. The architect never once argued about it, nor did the mechanical and electrical engineers, and I think we ended up with a great project. Like I said earlier, I'm going to skip through that. So, this is how BIM has been driving our campus, and this is how we actually have organized the requirements for all those involved in all our projects on our university. So, from a design perspective, you can see here, architecture, interior design, landscape design, civil, everyone, and very important, very, very important, quantity surveyors. If you don't get them on the table to use those models, so the first question I always ask at the first class D or C costing that we get from the quantity surveyor is, so tell me what you saw in the model. Tell me what you understand in terms of the logistics of construction, etc., etc. Do you see conflicts in the sequencing perhaps? And then if he doesn't answer the questions properly, I said go back to the model and you do your proper costing analysis. Because there's no sense in creating this incredible data and background and material if not everyone's going to participate. So that's very, very important. So in our projects, we obviously have a big execution plan. We do a return on investment kind of workshop where we actually get everyone involved, especially if it's a collaborative delivery method like construction management. We then get everyone around the table, maybe 20 to 30 people, including our operations and maintenance folks, our project managers, et cetera, to discuss where I think we can take advantage of the BIM process. And everyone's involved. It's not just us dictating it, but it's a collaborative kind of workshop, much like, pole planning or lean kind of workshops. Now, for the constructors, a lot of the stuff that we actually write into their request for proposals, the requirements, as you can see here, site logistics. So we actually expect, before sometimes they get their bid given to them, we actually want to see their model already pre-illustrated as how they're going to do the logistics on the site. And many of them come with a 3D model, and they illustrate how that's all going to work on the site. That's important for us, because remember, we have 55,000 students, 10,000 faculty and staff, plus numerous thousands of guests every day, all compressed into a small area, which means we need to understand all that. So, where they can, they have to show how they're going to deal with costing, scheduling, and fabrication to advance the schedule and to ensure that quality is maintained for the delivery of our projects. We require them to use collaborative software so that everyone's involved and on the same page, integrated document management, and where appropriate, co-location. So we have our teams in their offices, the architects in theirs, and vice versa. Very important. Very much like an IPD process. So they've been using the BIM processes during these projects for analytical purposes, for all sorts of investigations, all sorts of analysis, functional program development, etc., energy performance, and so on. But for us, even though they use it for hydrology, materials analysis, and so on, for us, the most important part is this in red. If we can get over this hurdle right here, all of this will fall into place. So I think BIM, if anything, just like LEED, L-E-E-D, has led the way in terms of sustainability and focusing on sustainability. I think it's very important for all of us to be aware how important the use of BIM is beyond just the tools and the processes. What we've done in addition to BIM, we've also integrated IPD principles. And so what we introduce into our RFP and RFQ documents is this particular language. We expanded a little more. There's no three-way agreement. By allowing this to happen also, it means that we're going to actually take advantage to try to reduce waste and harness everyone's knowledge and experiences and try to maximize and make things as efficient as possible and optimize wherever possible. So let me quickly walk you through some other images here. This is of our project that's won the award the other day. And let me show you how this was the catalyst for all our projects going forward. So this is for 2012. We established the BIM execution plan. This was delivered, and now we have multiple projects following kind of the same format. However, we've gone back and learned from this particular project, and now we're tweaking our processes and our deliverables accordingly, obviously. So the level of development versus the level of information. They not always have to be at 500. One could be LOD 100 with LOI, I don't know, maybe 800 if such a thing exists. So here's the landscape architectural work in a BIM environment. Just wanted to illustrate that we did do that. Site logistics from the general contractor, very, very important. All the software that we're using, and it's shared, sorry about that. This is sensitive. And what we're using it for, at every stage and where the levels. And we have actually a supplement that we give the general contractors. It's an 11 by 17. There's a column that for every discipline, what's expected, the minimum in terms of level 350, 400, 500. It's a tool that we use because otherwise you could end up issuing the IBC table element, which is 60 or 80 pages, and it gets a little cumbersome. So we condense it into something very, very small. Our models, which then, in this particular case, there was 85 models that got integrated from everything from clash detection and interferences were explored, and that's all the requirements that now we expect on all our projects. And for fabrication, from this, it goes to this, to eventually the shop drawings in 3D, to fabrication, to the actual installation on the facades, and we're working on a new project exactly in this same vein. By the way, those cassettes, what we call them, they had a 5mm tolerance all around. And those sections are probably about maybe 7, 8 meters long by about 4 meters tall. That's very tight. Some of the infrastructure came from Calgary, by the way, to Toronto. I think that was a no-no. Not that it came from Calgary. It's just the footprint. The footprint, that's a long way to pay for energy. All our plumbing and HVAC is done off-site and brought in and basically connected like a puzzle. That was the whole purpose of that, and we're doing more of that. On-site installation, it helps the guys put together all the glazing. And then more importantly, this. So we're actually identifying the assets. We already have a list that's approximately about 120. It's been vetted by a number of people that deals with our operations, energy, maintenance, and so on. And now we've kind of calibrated that to those 120 elements, and that's being incorporated in our BIM execution plans and issued to the general contractor with the RFP in advance so they know what they're getting themselves into, not after the fact. So we have our coding, that university coding for our facilities and so on. So let me go forward. So this is going to be a state-of-the-art building. It's just opening in a couple of months. The solar chimney is quite interesting. This is 70% net zero ready building. So, and the complexity of this building all around had to be done in BIM. This is a night view. Our new student center that just opened about 3 weeks ago was done in entirely collaborative BIM as well, and for the purpose of operations and maintenance. For the students, now the students are going to get a little crash course on how to take data out of a Navisworks model or maybe one of these other softwares that are maybe easier, so they can manage and operate their building because they're the operators and maintainers of their building. For landscape work, so I'm just about, what do I have here, another 10 minutes or so, 15 minutes. Okay, I'm getting there, so bear with me. This is an incredible project where we're going to actually integrate photovoltaics onto the skin. We're looking to do mass timber in this particular project to basically offset the carbon of our projects, because we are now required to do most of our projects, all our new projects going forward net zero. We're looking to do this as a net zero, net carbon building, and using passive house design, sort of a German, Austrian kind of process for ensuring that our buildings are super insulated and thereby not rely on basic carbon-focused fuel to basically heat and cool our building. So we're really excited about this building. Notice the twist. That's on purpose to self-shade. On the south side, it does the same thing to cut the angle. So let me finish off with a few slides about the benefit of BIM for your business. So again, I want to come back. I've probably already spoken about some of these. Improved building design. There's no doubt. Information streamlining and integrated workflows. Very, very important. Building performance and sustainability, and that's really our focus. That's always been our driver. When we actually brought the operations and maintenance folks to the table to have a discussion about this, this is what we spoke to them about, so that they understand what our purposes was. It wasn't to make those beautiful BIM models or 3D models, as Raphael put it earlier. And yes, our users love it. And the decision making today is so much quicker when you actually show your users the information in a 3D environment about anything in particular, small or large, happens a lot quicker. People actually, you have to remember, a scientist who does biology research, how are they going to know if you show them something in 2 dimensions, what it means, what his lab is going to look like and perform? So you have to use the tools that's available. So, and of course, accurate costing estimated compliance. You can actually incorporate the whole fire separation, the entire basically code and life safety systems incorporated into the BIM. You can actually isolate that into your model and actually basically out of fingertips actually understand where the complexities of the code and life safety systems in that building are, if anyone ever asked or needed to know, for example. And I think when we were talking about Singapore and doing BIM submissions for their applications, I can see actually a plans examiner actually reviewing that model, isolating the fire separations and seeing it all in its holistically and how it actually integrates with the rest of the building. I see that future coming very, very soon. Enhanced branding for a university becomes very important. You know, I always use the three principles of architecture that was presented to the world about 100 years BC by Vitruvius, who talked about commodity, firmness, and delight. And it's true. I think you need a balance of that. You probably understand what that means. Commodity, it has to use a function, serve a function. Firmness, it has to last, and it has to be beautiful. And for a university, the balance of all those three are very, very important for us. So let me keep going forward. The return on investment, as you can see, 20% reduction in building costs, reduction in conflicts and rework, very important, between 47 and 65%. Better performance altogether in terms of the infrastructure. And this is statistics from the USA. Getting close to the end. Facilities management, obviously complete and accurate data, very, very important for us. Real-time performance data. And if we can find that data very quickly and make it simple for those users and those who consume that information becomes very important. So reliability of as-built drawings. So let me just take you. This is why we do what we do, because we're trying to focus in this area here, the 6D and 7D, which has already been noted a number of times. So our future vision, I'm getting close to the end. It's 97. I got 106 slides, so I'm almost done. Progressive photographic records. We actually are embedding now progressive photographic records from the day the hole is dug for the foundations. All that's being tied to the BIM model. So you can actually go back and drill back to exactly what was put inside those walls and those floors. More importantly, I want to draw your attention. The commissioning training videos are being attached to the BIM model so that if a new person comes to the operations maintenance and they don't have the history, the institutional history of that building or that campus, they can actually go through those training videos, walk through the building with the actual training in a virtual environment. Isn't that clever? So all our three major capital projects are under construction right now. They're all going to be delivered that way. We also require basically the final as-built record model be issued back to the consultants. They review for compliance as an as-built model, and then given back to this entity that then links the models with the video and the photographic records. And we're also looking at tying in BIM, and we started with basically point cloud scanning for a number of our projects, especially for some major renovations. We're undertaking one like that right now. So that becomes very important because that's then our point of truth at that moment. It's that scan, not the drawings that are 40 years old in my office or someone else who's going to basically do a takeoff on that space. So some of the challenges we are dealing with BIM and GIS, as you can see here, is the compatibility of software, it's training, the maintenance of the data, who does it, when, how, and so on, and just general data integration. So I'm going to skip through this because I've already spoken about this. We've gone, and very important. So AR and VR is very part of every process that we undertake, especially with new construction and major renovations. We actually put it into our request for qualifications in RFP so that the architects actually leverage the tools that they have available. It's made such a difference with our users on our campus. And so our dream is to have our energy manager and our operations folks to be able to go out and do exactly this on site with their smart tablets. So we started to test this already, and that's where we're headed. So let me finish with 2 slides coming up. So some takeaways. So definitely, we have a working group, a BIM working group, we established in 2014, and it's made up of planning, design, and construction, space management, operations, maintenance, engineering services, information technology, finance, procurement, and legal. Get them all at the table early, talking, to learn about what BIM is for each of them and how it's helping the university at large, in your case, your own organization. We meet once a month. If we can, at least quarterly is what I would recommend. Get them involved very early and get those subject matter experts involved in all sorts of projects, because otherwise, without their buy-in, you're not going to get... Remember, the data is power, so that the more you can demonstrate for them that information that they have, the more important it's going to be in the way they run their... So the final slide, or second last slide, is basically it does not apply to new construction. It applies to also existing buildings. You have to remember that. Start small. Use some pilot projects like those Robotics Pavilion or that existing facility. That's how we started. So I always encourage other owners to start somewhere, somehow. Talk about the infrastructure of technology. So we've been working with our IT division of the university to help us to upgrade all our computer systems, our servers, and so on, because all our computers are in our office. We're about a staff of 30 in the one group. We had to upgrade most of our computers and et cetera, et cetera. It's, you know what, it's the cost of doing business. And I think if you really are committed, you have to make that investment. Work closely with your procurement department to establish the parameters that you need in the deliverables very early in your RFQ and RFP process. If you don't do it there, you're not going to get anything that you need to receive at the very end as a deliverable for your purposes that you intend. Be very clear with your deliverable requirements. Don't be wishy-washy. And I think Raphael from from Infrastructure, Alberta Infrastructures, noted that these statements. I once received an email from a procurement divisions of all the colleges and universities in Ontario that said, "Can someone tell me what this AutoCAD BIM is?" I didn't quite understand the question, so I wrote back 2 pages long a response. I had to, because this is what's happening out there. So I think we have to ensure that the definitions are very important. So we actually established what a design model is, that it gets issued for construction, for tender, then issued for construction, then what that model is as an as-built, and when it becomes a record model. So that's clearly defined in our execution plans. Model integration becomes very important between the consultants and the contractor. So we actually ask our architects and engineers that you have to share. You have to play in the sandbox. Your model becomes their model. Your model is our model. Your model is our model. And this is how we work on all our projects. And because I always get that question is, who does the model belong to? And my answer is always, all of us. If we're all inputting into it, why can't we all own it? I know there's going to be intellectual information from the architect's engineer, but I think it's important that we share that information. Determine how the data will be used for FM and operations, and always, always make sure your contractor builds to the model. You see, we audit their model once a month during construction. We see the evolution of that model. We understand what's getting inputted into that model, and only then they can send us the final model. We do the same thing with the consultants. At every stage of schematic design development, we review the model for basically quality control. Not that we don't trust them, but as my assistant vice president says, every time we hire a consultant team, that BIM model to us is worth $5, $7, $10 million. That's $10 million of intellectual property and information that went in there by that entire consultant team. So he understands the importance of that and the value then for going forward. So establishing parameters of how you actually receive those models becomes very, very important. So remember that. Build to the model. So with that, thank you. Any questions? I know there was a lot of stuff. Lots of pictures, I know. But I think I did it. It's still 10 to... Yeah. Any questions? It was all clear? I said it all? Thank you.
We got a question right here.
No, if there's any questions, happy. And you know what? My email is right there. You're welcome to send us emails and requesting what we can provide you. Because there's some stuff that we don't provide, but almost anything that we provide that's public, or whatever's in our RFQs, RFPs, etc., happy to share with everyone and anyone. So,
sorry, that was my question. Is the BIM execution plans included in that as well?
Say that again, sorry.
That was my question. Is the BIM execution plans included in that information that you publicize, that you share?
Yes and no.
Okay.
Yes and no. So we can make it available to you. That's not a problem. Yeah.
Thank you.
Yeah, no problem. If it's another university, we don't give it to them. You know, universities the way they are. They're very competitive in nature. So, any other questions? I know that was a lot of information. Well, thanks very much for your attention. I do appreciate it for the opportunity to share our experience with you guys. Thanks very much.